Mathematics is very important to the world. It is all around us in everything we do, and it is used in many things that people would never expect. But sometimes, we tend to forget how much mathematics is involved in our everyday lives. So, I'm here today to teach you the measures of relative position for my performance task in mathematics in the modern world. But before we proceed, let me introduce myself. Hi, good day. My name is YUMANG from BSP1, and I will be assisting you to better understand the concept of C-scores. So without further ado, let's start. I will be flashing here my screen so you can better understand the topic. Like I said, our topic today is all about measures of relative position, specifically C-scores, and our agenda consists of determining what is the definition of a C-score, its importance in our everyday lives, the formula to calculate the C-score, and of course, an example problem that will undoubtedly help us to understand the topic better. What is a C-score, you may ask? So to formally start our video, let us find out what is the definition of a C-score. So, a C-score describes the position of a raw score in terms of its distance from the mean when measured in standard deviation units. Second, it is also known as standard score because it allows comparison of scores on different kinds of variables by standardizing the distribution. And lastly, C-scores are a way to compare results to a normal population. For those of you who may be asking, what is its importance in our everyday lives? Let me answer that. First, it allows individuals to calculate the probability of the score, most especially those occurring within a standard normal distribution. And second, it enables us to compare two scores that are from different samples and scores that has a different means and standard deviation. Now you know why it is important, let us proceed on how we're going to calculate the C-score. We are going to use the formula of value minus mean all over the standard deviation. As for the population data, we'll be using the formula of x minus the mean, and as you can see, the symbol for the mean in population is the mu symbol all over the standard deviation. And for the sample data, we will be using this formula, which is the x minus the mean over the standard deviation. When getting the C-scores, here are three things to remember. So first, you need to know if the C-score is positive, then the positive score is above the mean. While if the C-score is negative, then the score is below the mean. And lastly, if a C-score is 0, then the score is same as the mean. Now you know the formula and the things to remember. Let us practice getting the C-score with a sample problem. So here is the sample problem. A dataset has a mean of 75 and a standard deviation of 11.5. Find the C-score for each of the following. These are the given values. First is 85, second is 95, the third is 50, and last 75. Using the formula of the sample, which is the value minus the mean over the standard deviation, let us now put our skills to the test. We will start answering letter A with the given value of 85. Remember that the formula we will be using is value minus mean over standard deviation. The first step is substituting the numbers. 85 as the value minus 75, which is our mean, all over 11.5, which is the standard deviation given. So 85 minus 75, the answer will be 10, divided by 11.5, the final answer is 0.87. 0.87 is a positive number, therefore it is above the mean. Second one is letter B with the given value of 95. So remember that the steps are the same. We need to substitute the given numbers to the formula. 95 as our value, minus 75 as our given mean, all over 11.5 as our standard deviation. The first is subtracting 95 to 75, the answer will be 20. So 20 divided by 11.5, the final answer is 1.74. Again, 1.74 is a positive number, therefore it is above the mean. Next is letter C with the given value of 50. Again, we need to substitute the numbers in the formula. So 50 as our given value minus 75 as our mean all over the standard deviation of 11.5. So 50 minus 75, the answer is negative 25. If we divide this to 11.5, the final answer is negative 2.17. So since negative 2.17 is a negative number, therefore we can conclude that it is below the mean. Last but not the least is letter D with the given value of 75. So we need to substitute again the numbers, 75 as our given value minus 75 as our mean, all over standard deviation of 11.5. So 75 minus 75, the answer will be 0. And if 0 is divided to 11.5, of course, the final answer will be 0. And as we said earlier, if the score is 0, then it means that it is same as the mean. We have now come to the end of our discussion. Once again, my name is QUISHA Margaret Yumang from ESP 1. I hope you learned something. Thank you for listening. Have a good day.